good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 38 should be on your screen. And it's given 3, 5, 1, 4, 1. Number 1, compute the measure of central tendency and sketch a box plot. And number 2, compute the standard deviation and the bell curve. All right, let's get to work, please. All right. Number 1, compute the measure of central tendency. What'd you get for number 1? Alex, go. Mean 2.8. Median 3. And mode 1. Hands if you got that. Looks about right. And then let me do the box plot right above that. We need Q1, Q2, Q3. Pass someone, please. Q1, Q2, Q3. Who? Jaden. Q1. 1. Q2. 3. And Q3. 4. Our max was 5. And our min was 1. What do you guys notice? There's only one whisker, right? Isn't that weird? All right. So far, so good. All right. Standard deviation. And we also need the mean. For the mean, I'm going to use mu. All right. Jaden, pass someone for mu. Who? Drew? Luke. Oh, my bad. Luke. For the mean? 2.8. How about standard deviation? 2.16. 6.3. Hands if you got something like that? Yes? All right. I sense a disturbance in the force. For standard deviation, what'd you get, Jerry? 1.6. 1.6. Hands if you got 1.6. Looks about right. What? All right, so let's do this. So double check this. And here's our bell curve. Our mu, or the mean, is 2.8. And our standard deviation is 1.6. And below 1 standard deviation, so this would be 3.4 and 1.2. No, 4.4, my bad, 4.4. So my normal range is from 1.2 all the way to 4.4. All right, hands if you got something like that. All right, make sure you send me that warm-up, please, on Nearpod. Here's the agenda for today. Warm-up number 38. Today we're moving on to measures of variation, so make sure you stay focused. Get a Cornell note ready, please. And tonight's home play is on page 143 of your text. You're doing numbers 1 through 8 even only. Bless you. Numbers 1 through 8 even only. Page 143 from your text. Once again, warm-up number 38, measures of variation, and your home play page 143, numbers 1 through 8 even. All right? So last weekend, I hope you did something nice at home, yes? Wash the car, clean the house, clean your room, make some chilaquiles or something, or maybe massage somebody's feet. Sometimes they're tired, you need to massage feet, right? Oh, really? Your code for this presentation is K7PMS. K7PMS. All right? Your home plate, it's only 8 problems. All right? I'll give you some time to set up your Cornell note. You do need a fair model. You do need a fair model. Anyways, here we go. Our objective for today, I can summarize data and compute the measures of tendency. I can summarize data and compute the measures of central measures of variation. Measures of variation. Yeah, so we're moving on. If you notice, for the past week or so, we were working on measures of central tendency. Today we're moving on to measures of variation. And we do need a fair model for that, yes. 23, yes. All right, measures of variation. Write this down, please. What are measures of variation? Measures of variation are commonly used measures of variance for a set of numerical data that represents spread of a data set. Measures of variation are commonly used measures of variance for a set of numerical data that represents spread of a data set. Write that down, please. I'll elaborate on the definition. All right, so let me elaborate on the definition. Here we go. Those that are distracted, you're probably going to miss the point. Here it goes. We were working on measures of central tendency. And those measures, according to the definition, are what we use to measure some of the data and everything that happens within a center or a focus of the data. That's why they were called measures of central tendency. However, today we're moving on to measures of variation. Look at the definition. It says commonly used measures. We're still using measures, but for what? Of variance. What does variance mean? That it changes or it varies. Okay, so measures of change for a set of numerical data that represents the spread. What does that mean, Mr. Q? That it's no longer going to be in a center or focus. It's going to be what? Spread throughout. Now, we've been doing this, by the way. You're like, what? Yeah, like I said, we've been doing this, but without me giving you the actual terms and formulas. You already have the work done. You're going to realize that right now. So look up. What are the measures of variation? Writing utensils down, look up to the screen. Here's the first one. Tell your neighbor what that is. Range. Have we been doing that? Yes. Here goes another. Tell your neighbor what that is. Yeah, standard deviation. We've already been doing that. Here goes another. Oh, and by the way, it looks something like this, right? We've been working with those. And here goes the third one. It's only 3. Now, I haven't given you the name of this one. I just called it standard deviation squared. This has a name. This is known as the variance. This one, last one's known as the variance. It's known as the variance. So what are the 3? Range, standard deviation, and variance. Copy that, please. Now, as you're copying that, obviously, by now you should know 3 non-examples. Tell your neighbor what you would write for your 3 non-examples. What would be your 3 non-examples? What would be your 3 non-examples, Ethan? Aguirre. Yeah, he said mean, median, and mode. That is correct. So write those down as non-examples because we already finished those. Copy that. So, for the sake of time, here we go. Hashtag this data. Whenever I give you data and we're talking about measures of variation, the data is going to be what? Spread out. It's going to be spread. We're going to be using those measures to find out that spread. And of course, hashtag data. Maybe if you want to do one more, hashtag variance or change in data. Remember, variance means change. You can use that as also as a hashtag. All right, so once again, do we have the three measures of variation? Yes? All right, so look up really quick. We already have our formula, so underneath your Freyer model, write data measures. The first set was known as central tendency. The second set is known as variation, which is what we're going to work today. That's why I have it in green. And the third set that we're going to be getting to is known as measures of position. Okay? So, copy this and then write down your three that go here for central tendency. And what are those? What are those? What are those three? And Angel, give us the three measures of central tendency. Mean, median, and mode. That is correct. All right, and before you forget, turn to your neighbor to let them know the three measures of variation. What are the three measures of variation? Three measures of variation. Three measures of variation. All right, what are the three measures of variation? Jerry, go. Range, standard deviation, and what else? Variance. That is correct. And the last one, measure of position, we're going to get to pretty soon. So keep that in mind. I'm just showing you the roadmap as to where we're at so far. Okay? Variance. Fine. Let me rewrite that. There you go. Better? All right. Anyways, here we go. So we got that. Formulas we're going to get to right now in a little bit. So copy this one, example number Q. And it reads, compute the measures of variation for 1, 7, 3, 6, 5. 1, 7, 3, 6, and 5. Now, we've been doing the work, but I want us to organize ourselves because some of you go really fast with your computation, which is fine, but I just want to go through the process one more time to make sure we got all the process down. So, I'm going to make a table, and you do the same. Is that crooked or is it me? It's a little off, yeah? Right there? Yeah? All right. My goodness. All right, here we go. Since you're very talkative, Alex, what do we label our first column? What do we label our first column? Very good. X, that is correct, which is all data values. Tell you here how they go on that column. Very good. In ascending order, oh my goodness. Starting with 1, 3, 5, 6, and 7. All right, so what do we do with that data now that it's in ascending order? Tell your neighbor. What do we do? What do we do with all that data, guys? Add them and divide by 5, which is known as the mean. And for right now, we're going to use the symbol of mu for the mean. So what are we doing? We're finding the sum and dividing by the number of numbers. Okay, find the sum, dividing by the number of numbers. So, computers, calculators, calculate. 7 plus 6 plus 5 plus 3 plus 1, that is 20 what? 22 divided by 5 numbers. So what is 22 divided by 5, everyone? 4.4. All right, so far so good? All right, so think about the process. What did you do next? Because right now you guys already know how to do standard deviation, yes? What do we do next? Subtract. Yeah, so we take the value and subtract the mean, or mu. Label that column x minus mu. So we go 1 minus 4.4, 3 minus 4.4, 5 minus 4.4, 6 minus 4.4, and 7 minus 4.4. All right, so let's go over here. 1 minus 4.4 is negative 3.4. 3 minus 4.4 is negative 1.4. 5 minus 4.4 is 0.6. 6 minus 1.4, 4.4 is 1.6. And 7 minus 4.4 is 2.6. All right. What do we do with that data? Tell your neighbor, what do we do with that data now? Emilio, what do we do? Square it. That is correct. Squared, 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 squared. So what would we title over here? Look up, please. What do we title this? Alec. X minus mu squared. That is correct. So label that. So let's see. Negative 3.4 squared. Calculators, calculates. 3.4 times 3.4 is 11 what? 56. 11.56. 1.4 times 1.4 is 1.96. 0.6 squared, that's 0.36. 1.6 squared, 2.56, yes? And 2.6 squared, 6 point what? 76. Okay. Bless you. Bless you. All right. So, what do we do next with that data? Tell your neighbor, what do you do right after that? You already know the process. What do we do next? Add. I heard add. What do we call that in Greek? Or the symbol? Yeah, the sigma. Yes, sum of x minus mu squared. So let's find the sum. That's sigma. So 11.56 plus 1.96 plus 0.36 plus 256 plus 6.76. Looks like Angel's got it. We'll just give the rest of you a little bit more time. Looks like Alice got it. Jenne's almost done. Looks like Drew's got it. Jaden's almost done. All right, what'd you get for the sum? Sean, what'd you get for the sum? 23 point what? 0.2. Hands if you got something like that. All right. So, remind your neighbor, now that we have the sum, what do we do next? What do we do next? What do we do next, everyone? Divide it. So, look up. What would I label the top? Well, the sum of x minus mu squared divided by what? By n. That is correct. In this case, 5. So let's write 23.2 divided by 5. What does that give us? Calculators calculate. 1.64? 4.64? But I'm going to label it like this. Watch. Didn't we get the mean of all these numbers? What is this known as? Standard deviation squared, also known as variance. That is correct. So that was 4.64, you said? Yes? 4.64. This is our variance. All right? What do we do at the end? Well, Mr. Q, we still need our standard deviation. How do we get our standard deviation? Remind your neighbor. Everyone, what do we do? So what will we label this? Square root of all of that, yes? The sum of, parentheses, x minus m squared over n, taking the square root. So, standard deviation of that. Man, some of you come so energetic, like if you drink coffee or something in the morning. All right, what is 464? Square root of 464. What'd you get, Jaden? 2.15? Yes? All right. Hands if you got 2.15? Yes? All right, and this is known as what? Standard deviation. Well, guess what? All this process that you've been doing on a daily basis almost, that I give you guys these numbers to do, is an actual formula. Do you guys see it? To get the standard deviation, what is our formula, everyone? Taking the square root of the sum of x minus mu squared divided by n. But do you know what each component means now? Yes. So do me a favor, copy this formula in your formula page. Copy that, please. But we're still not done, because it says compute the measures of variation. We're missing one. We got standard deviation, we got variance. Which one are we missing? The range. That is correct. So range is 7, which is the highest, minus 1, which is the lowest. So the range is 6. Range. All right, from 1 to 5, how comfortable are you with measures of variation? From 1 to 5, how comfortable are you with measures of variation? Yeah, 5, 5, 5. Yeah, and like I said, this time I just wanted you to see column by column the entire process to make sure you got it, okay? All right. So write that down on your formulas. So here goes the entire process. You get your numbers in ascending order from least to greatest. Find the mean or the mu. From there, subtract the numbers from the mu. Square all these differences. From there, find the sum of the differences of squares. From there, divide by the number, and that gives us the variance, or standard deviation squared. From there, you take the square root, that gives us the what? Standard deviation. and make sure you get the range. All right? So, with that said, that's pretty much your home plate. Okay? So let's move on to, what's that? It's only, no. It's 8 problems even, but only like, there's only 3 of them that are like that. Yeah. The other ones are just answering questions. All right. Look up really quick before you continue. It reads, example super Q. It says, compute the measures of variation. A testing lab wishes to test 2 experimental brands of outdoor paint. Pay attention to this part. A testing lab is going to test how many brands? 2 brands of paint. To see how long each will last before fading. Does everybody know that outdoor paint with the sun, it starts fading? Some of you, I had a little Corolla that with time, since I used to park it outside, the sun just like ate up the paint. I don't know, you know, it's just, what's that? Yes. So they didn't do a good job with the paint job from factory. They should have put another coat of paint and maybe 2 more coats of clear. So anyways, here are 2 different brands, brand A, brand B, to see how long it lasts before it starts fading. So then it says, the testing lab takes 6 gallons of each paint test, and since the different they have different chemical agents are added to each group, only 6 cans are involved. How many? 6 cans. 1, 2, 3, 4, 5, 6. 6 for each brand, okay? And basically, they want you to get the measure of variation, but the results, all these numbers are in what? In months. So let's see. Look up to the screen. Make sure we understand what we're looking at. Brand A, here's the first number. What does that mean? Tell your neighbor, and then Alex will enlighten us. Tell your neighbor what that 10 means. What does that 10 mean? All right, let's see. Alex, what does the 10 mean? I know, because you were paying attention. It says the result in months before what? To see how long the paint, what? Fades. So what does that mean for the first bucket on brand A? That after 10 months it started what? Fading. Which means the next bucket, it took how many months? That's 5 years before it started painting. How about the next one? And so on and so forth. So these are months, okay? So, can you, which I'm pretty sure you do, can you find me the measures of variation for each of these brands? Yes? So, to go a little bit more expeditiously, turn to your neighbor, let them know which one are you going to find the measures of variation for, and they're going to do the other, and then compare both. Okay? So, yes. So tell your neighbor which one you're going to do. All right? So do me a favor, find me the measures of variation, but since you guys are experts, I want a bell curve as well for each. From there, come to a conclusion with your data. Go. I'll stop the video right here.